Hello, everyone. My name is Itay Shakury. I'm from the open source team in Aqua Security.
And I'm Yaniv Agman from Team Nautilus, Aqua's research team. Today we wanted to tell you about the latest release of Tracee, version 0.3. This version focused mostly on engineering efforts to move from BCC to libbpf. But before we cover the details, let's talk about the motivation for this move. Previously, in order to compile and load its BPF program into the Linux kernel, Tracee used Go BPF, which has Go bindings to BCC. Using BCC and Go BPF has several drawbacks. First, it compiles the BPF code on every execution of the program, which makes its startup time to be long. For example, it took about 5 seconds on my machine to start Tracee. Second, it requires BCC to be installed on the target machine, which can be problematic on some environments. Android devices, for example, have no glibc and some other packages which are required to run BCC. Moreover, cross-compilation is not possible when using BCC, as the compilation takes place on the machine which executes the program. Finally, features developed in the kernel take some time to land in BCC, and even longer time to get into Go BPF, if at all. For example, BPF compile once, run everywhere, and ring buffers are not supported in Go BPF. In contrast to BCC and Go BPF, libpf is being developed as part of the Linux kernel. It is well maintained and always up to date with the most recent features. The only problem with porting our code to use libpf was that there was no library which provided Go bindings to libpf. So we decided to develop it by ourselves. libpfgo is the result of this development and is now part of the Tracee repository. We made libpfgo available as a Go module, which can be used by other projects as well. libpfgo is a thin wrapper around libpf. It uses cgo to call libpf functions and wraps these functions with Go structs and channels. Using libpfgo, it is required to perform compilation only once on a given machine. Then, the compiled BPF object can be used in future executions of the program, which makes its startup time much shorter, almost instantly. Looking forward, using libpf will allow us to support compile once, run everywhere. With this technology, kernels which have BTF support will be able to run Tracee without performing any compilation at all, and execute it just like any other regular program. And now let's move to Itai to demonstrate this change. Itai.
Thanks, Yaniv. So I'm going to share my screen and show you a little bit of how to use the latest version. So I have Tracee here. I'm going to quickly build it using make build. Now the build process is slightly changed in order to accommodate the new libpf changes. We won't go into that for now, but the result is still the same. If we take a look at the dist directory, we see that the make build has created a bunch of stuff for us, but most importantly, the Tracee binary. So we can just execute it. And I'm going to execute it with a new flag that we've added that's called --debug. That's just for helping us see what's happening behind the scenes for now for educational purposes, let's say. So I'm going to run it. And you can see that it is attempting to build the object file because it didn't find it in any of the predefined locations that it searched for. And it actually built it and it placed it under the temp Tracee directory. This is the resulting file. So this is just to match the previous experience. If you are used to just running Tracee and expecting everything to work, it still just works, right? If I run it again, it will be much, much quicker because, as you can see, it already found the BPF object file under the temp Tracee directory. So the first time that you execute Tracee, it persists the BPF object file, and then later executions can just find it there. So this means that we actually don't need the baggage of the compiler tools and all of that toolchain with Tracee anymore. We can actually ship a lighter weight version of Tracee that you can just hand this pre-built eBPF object file to, and it will just use it. And this is exactly what we've done with this release. I want to show you the Docker images for this release. So this is familiar from the previous release. We have the regular version of Tracee that you can use and run. We have actually reduced the size a little bit because we moved into using Alpine images. But we now also have a slim version of Tracee, which is actually even more lighter weight, and the differences, as you can see, are quite stark. This is a very lightweight version of Tracee that cannot compile the eBPF object by itself. It expects you to provide the eBPF file too. So we already know that we have the eBPF file under temp Tracee, right? This is the result of our previous run of Tracee. So let's first try to run this slim version as a Docker container with no further arguments and using the debug flag as we did before. And we see that it tried to build the eBPF object file, but it couldn't because this is the slim version. It cannot, it doesn't have the capabilities to do so. If, by the way, I was running the regular version of Tracee, it would work, but we don't need it because we already have the file. So let's just provide the eBPF file to Tracee, to this slimmer version of Tracee. So the difference here is that I mount the temp Tracee directory from my host to the container so that Tracee in the container is able to find the same eBPF object file that I compiled just a moment ago. And I'm also just passing it into head so we won't have a lot of the background noise that the traces produce. I want to be able to see just this part here and to show you that it worked. Tracee, the slim version inside of the container, was able to just use the file from the host. The only requirement here is that the version of Tracee and the version of the kernel that you build the eBPF object file will match the version of Tracee that you are running. This is the only requirement. And this starts to look like a more realistic scenario for how you would run Tracee in the real world. You wouldn't want to build and compile the eBPF program every time, which means that you also need to provide the kernel headers to this Tracee every time. Now you don't need to provide the kernel headers to Tracee whenever you run it. You just need it once when you compile the eBPF program, and then you can use the slim version of Tracee to pass it in. So if you want to build the eBPF file on your environment, you can do it just as I did now, or you can use the new make target, make BPF. And it also has a variant of Docker equals 1. Let's run it actually. And this will run the entire build process inside of a Docker container that contains all of the dependencies. And the result of this is, let's look at the dist directory again. This is a new file. It didn't exist here before. This is the result of make BPF. And now, if we are going to run Tracee again for the last time, we see that it picked up this version of the eBPF object file from dist, not from temp Tracee, because dist takes a higher precedence in the search order. So we've already covered temp Tracee, and if it finds the eBPF object file right next to the executable, it will prefer to use that. Or if you want, you can just pass in an environment variable when you run Tracee that's called Tracee BPF file. You can just point it to whatever you put the BPF file, and then you just start Tracee, and it will override all of the search patterns and we'll use just this path. Great, so this was a quick introduction to the latest release of Tracee. We also talked about libpfgo, our newest wrapper of libpf inside of Tracee. So that was it. Thanks and see you next time.
Thank you.